Take two. All right, guys, this is Mrs. Lehman from Math with Mrs. Lehman, and I'm here with my wonderful third period class.
Hello.
They are currently trying to convince me into starting a separate YouTube channel, but that could be interesting. Anyway, right now I'm going to stick to math, and that is what we're doing today. We're finding the mean absolute deviation, and the abbreviation for that is MAD. So anyway, or the acronym would be MAD. So up to this point, we've been kind of looking at measures of center, and we said, just kind of looking at the data, we can see that the measure, or that the center is this number. And we didn't really base it on anything other than just kind of eyeballing it. And then we kind of said, okay, we need a technical measure of center, and that would be to find the mean, right? So we've done the same thing with variability. We've looked at data sets, and we have said that one data set is more varied than another, but we didn't really have any proof. So what we're going to do today is actually define variability with mean absolute deviation. All right, so we are on page 48 in your module, at least my students. So anyway, we talked about temperatures for New York and San Francisco, and how, New York had a larger degree of variability than San Francisco because the temperatures in San Francisco all tended to hover right around that average temp of 63, or 64, I should say. And New York City, even though it had a mean temperature of 63, it had temperatures in the 50s and temperatures, in the mid 80s. So we're going to look at some cities. Now, these are absolutely ridiculous examples, but city A, temperature is always what in city A? 64, 63, whatever. 63. It's always at 63 degrees. That's insanity, right? That does not happen on Earth that I know of. Anyway, city B, you can see it has some variability to it. City C, again, some variability. City B, would you say B? City D, what would you say about city D compared to the other ones? Maya, nice and loud.
It's more spread out.
Very good. It is more spread out. City E and City F do not exist on Earth. Again, you're not going to have just two temperatures and nothing in between. It's kind of odd. But anyway, you can blame the New York State module makers for that one. And then City G has a little variability, but it is still kind of mounded around the mean temperature of 63 degrees. So question 1 asks us, which distribution has the smallest variability of the temperatures? Which one would have the smallest variability? Kyle, nice and loud.
City A.
Very good. City A is correct. Why? City A, because... Maya?
It's just what temperature on Earth.
Very good, because the temp is always 63 degrees. Always and forever. All right, so we have, again, these different degrees of variability. We're going to now define this. So we're going to actually skip a bunch of questions because chances are people are watching this video because they are confused on their homework. So if you go to page 48, there's again the dot plot of city G, and we could look at all the dots and say what the temperatures are for each of these. And let's see, what are the temperatures for city G? Go ahead, William.
They seem to be about 53, 62, 60, 64, 63, and 70.
Yeah, they're kind of all over there, right? So officially we have a 53, 57, a few 60s on that list. We have some 64s and a few 68s and a 70, all right? So what we're going to do today is figure out, on average, how far away are the temperatures from that mean temperature of 63 degrees, okay? So I would like to give this example. So let's say I had given a quiz, and the average score on it was 80. All right. So let's say that the average score is 80. Elijah got a 100 though. What is the difference between Elijah's score and the average of 80? If he got a 100, what's the difference here?
It's 20% more.
Well, yeah, but we're not talking percent. We're just going to say 20 points.
20
Okay.
points more.
Yep, you're correct, but it's 20 points, right? So that's what we call the deviation, right? So his score, Elijah's score of 100, deviated from the mean score of 80. Is there anyone that I can pick on in here? All right, I'm gonna pick on Julius. All right, Julius, he had a bad day. He got a 60. Julius, how far did your score of 60 deviate from the mean of 80?
20. Shoot.
What's it?
I forgot.
What's 80 and 60? What's the difference between 80 and 60? Everybody, what's the difference between 80 and 60? 20, right? So Elijah was 20. What was that?
I said that.
Oh, you did? I didn't hear you. You're so quiet. Sorry. Sorry, Julius. So Elijah had a score that was 20 above. Unfortunately, Julius's score was 20 below the average. So we have 20 plus 20, right? There's still 20 points away, whether it's positive or negative. Divided by those two kids, what was the average deviation for these two? What's the mean deviation here? I'm going to pause this for a quick second. Okay, so anyway, what you do is you take the deviations and you divide that by the number of pieces of data you're doing that for. So if we flip the page, and you guys can actually just, I think, open it up in your module book, so it's good to see both at the same time. They have this pretty little chart that says temperature. These are all the temperatures in the left-hand column for city G. Right? That's where all of these numbers came from. The deviation column, you'll notice they take that temperature and put it right here, and all of these numbers are our mean. Okay, that was our mean temperature of 63. So if you had a temperature of 53, you would say, well, that's 10 degrees below what we normally see, right? So that would be a result of negative 10. Now we're going to flip to the next page and go to this bigger chart, because most of this is the same work, except for they add the column that we really need to have here, which is the absolute deviation. So if you look on the first row, we have 53 for the temp. 50, you take the temperature, subtract the mean number. In this case, it was 63. It'll be different for every data set, right? But for this one, it's all 63. So 53 minus 63, you're going to find a difference of 10. And because 53 is 10 less than 63, it's a negative. Now, this is why we call it mean absolute deviation, because even though it's a negative 10, it is still a difference of 10, right? So you're going to change all of these answers in the result column to positive. So let's put a little note here. Absolute value, that means it's always positive. Okay? And the deviation column, that means we are going to subtract the mean, the temp in this case, and mean. The result is the answer you get. All right, so there should be no mystery where these numbers are coming from. So let's go ahead and finish this chart. 64 is pretty nice because we have all this, we have like 1, 2, 3, 4, 5 of the same temperature, so the work's going to be the same for all of these. So 64 minus the average of 63, that means we're at what difference between the two? 1. Yep. So it's a difference of 1. It's a positive 1. And absolute value is always positive anyway. So even if you got a negative number in absolute value, you're going to make that positive. Okay. So we're just going to do that same work. It's kind of redundant, but I think it'll take about 2 seconds to do that. Now we're going to get to 68 degrees. All right, so what's my next step here? What do I have to do next? Julius.
68.
Perfect, Julius. We're going to subtract 63 from 68. So 68 minus 63, that's a difference of what? 5. So that month, it was 5 degrees warmer than the average yearly temperature, right? So that's a absolute deviation of 5. So 68 minus 63, again, is a difference of 5. The absolute value of 5 is 5. All right, the last one, we have 70. So 70 minus 63. Let's subtract those. What do you get when you subtract 63 from 70?
13.
No. Seven, yeah. Okay. A lot of kids, when you're doing subtraction in your head, you goof that up. So 7 in that month, that means that it was 7 degrees above the average. Okay, and then it was positive anyway, but we always keep our absolute deviations as positive. So the next thing we need to do is look at this little beautiful graph. They show it's kind of like a dot plot, but instead of putting dots above these temperatures, they're showing what the deviations would be from the mean of 63. And you can see the little balancing symbol there under the 63, showing that that's the mean. Now, when you look at these are all absolute deviations, so they're all positive. If you go back to page, I'm not sure which page, page before in your module, if you look at this, oops, what happened there? Anyway, if you look at this page before, you have all these negative numbers on the left here. Do you guys see those? Then you have all these positive numbers on the right. So if you were to add up all your negative numbers, you're going to have a negative 22. If you add up all your positive numbers, oops, can't forget the 7, what would all of our positive numbers be, do you think? Remember, this is a balanced little teeter-totter. 22, very good, Tim. These do actually add up to a positive 22. So you have your negative numbers balancing out with those positive deviations, and what happens is you get a 0. Okay, that's why we get a 0, because it balances out at the mean. We're going to go back to this chart, though, because we have more work to do. If we flip the page, I think this is one where in your book you guys can have both pages open at once. What I want you to do, I'm going to pause the video. We're going to add up. Oh, you're supposed to do that on the. Oops, just copied over, okay? We're going to add up all of our absolute deviations. So I want a total. Whoops. I want a total right here. Okay, what's the sum of all those deviations? I'm going to pause this so you do that. All right, so when you add those all together, you get 44. So we know that if you take all the deviations, you add them up, you're going to get, or the absolute deviations, you're going to get 44 in this case. Now, how many data values did we base that on? How many did we add there? How many values? Yes. 12, very good. So, to find the mean absolute deviation, what do you think we're going to do? And this is for part C. We're going to take 44 and do something with it to find the average deviation. Maya?
44 divided by 12.
Perfect. 44 divided by 12. All right, when you take 44 and you divide it by 12, you guys can use your calculator for this. Yep, you're going to get 3.6 repeating, right?
Yeah.
But they tell us we need to round to the nearest tenth. So what would that be to the nearest tenth? Yeah, look next door. See if that's... Yep, go ahead, Tim. 3.7, very good. So our MAD, our mean absolute deviation, is 3.7. And what that means is that typically in city G, the mean temperature is 63, and most of the other temperatures were clumped within 3.7 degrees of 63, okay? Now, if we had a mean absolute deviation of 10, right, that would mean that typically the temperatures are spread out 10 plus and minus, you know what I mean, around 63. So the higher the MAD, the higher the what?
The higher the variation.
Yep, very good. The higher the variability. That's exactly right. So the mean absolute deviation, again, is a method to define the variability of a data set. The higher the MAD, the more spread out the data is. The lower the MAD, the more tightly grouped the data is. All right? So tonight for homework, what you guys have is to just practice the same skill. So we're not really going on and on with this lesson, but just kind of a little intro. So you're going to have question 1 here in your problem set. If you guys flip to page 54, this question continues on 2 pages. It says, suppose the dot plot on the left shows the number of goals a boys soccer team has scored in 6 games so far this season. And the dot plot on the right, actually one's on top and one's on bottom, but whatever, shows the number of goals a girls soccer team has scored in 6 games so far this season. So you've got the boys team and the girls team, all right? And the mean for both of these teams is 3. So on average, they're scoring 3 points in a game, okay? But if you look at these distributions, you can see that the boys team has goals as low as 0 and goals as high as 7, where the girls team, their goals are all between 2 and 5 goals, right? So theirs is a little more tightly grouped. So which one would you anticipate would have the higher variation or the higher MAD? Would it be the boys team or the girls team? What do you think, Elijah?
The boys team.
Very good. So it's more spread out. This boys team should have a higher MAD when we're done. All right, let's see. It says before doing any calculations, which dot plot has the larger MAD? We just answered that. So the more spread out it is, that's the one with the higher MAD. So I'm going to let you write that down without telling you that. And then explain how you know. So how do we know that that one's going to have the higher MAD? Again, MAD is a measure of variability. So if it has a higher MAD, it means it is more spread out. It's more varied. Use the following tables to find the MAD number of goals for each distribution. So they already gave you the mean, right? First step of doing this is you have to know the mean. And our mean here was what for the teams? 3. Very good. And we're going to round to the nearest hundredth, it says. So on the next page, you have these 2 different charts. Now, I don't like that they did this to you. They kind of changed. Okay, so they're missing the piece of data that they showed you how to use earlier. So we know that 0, if they scored 0 goals, that's how far 0 minus 3 is a difference of negative 3, right? That's where they're coming up with that. And the absolute deviation, meaning how far is 0 from 3? 3, yeah, it's just 3, okay? That's where they're getting that number. So then they kind of kick back into doing what they showed you to begin with. So you're going to take your number of goals, you're going to subtract the mean. So what is 3 minus 3? 0. So that means these 2 both have a deviation of 0 because in those games they scored the mean amount. All right, the next one you're going to take 5 minus 3. What's the difference there? 2. Very good. So you'd write 2 there, and then 7 minus 3 is 4. So when you find the sum of all your deviations, that should always add up to 0. When you find the mean of your absolute deviations, that's when you're going to get, you know, a positive number to divide by. So what's 3 plus 3?
6,
Plus 2
8,
plus 4?
12.
12. So we know that they have 12 total deviations. How many games was that based on? So 12 divided by the 6 games that we see right here. So 12 divided by 6 is 2. So we know the boys team has a MAD, the mean absolute deviation equals 2 here. And then if we look at the girls team, we have to do more of the work ourselves here. So we're going to put, again, you put the number of goals here. We know the mean was what? Okay. So we could set these all up. You're taking the first number and subtracting 3 from it. Okay. So if they scored 2 goals, that was 1 below, right? What their average was, so we put -1. But then if we look at its absolute value, we know it's still within 1. So all these negative numbers that you may get will turn into positive numbers. So -1, this becomes 1. All right, so then we have a goal of 3, or 3 goals. The average is 3, so our deviation is what? 0, yep. So we're going to put 0 here. These are easy because you get to do the same math over and over again. 5 minus 3. 2. Yep, so that was 2 above what they typically get, but it's still 2 away from their norm. So anyway, you're going to add these deviations up. You'd always get 0 there. All right, 1 plus 1 plus 2. Tough math today, kids. 1 plus 1 plus 2 is 4, right? So 4 divided by 6. What's 4 divided by 6? Yep. Very good. You're going to get 0.666 repeating, right? So that's going to round to the nearest, what they want it to, the nearest tenth or hundredth. What did it say? Let me go back. Round your calculation to the nearest hundredth. So what would that round to for the nearest hundredth? 0.67. Very good. So the MAD here is 0.67. Now we have some proof to say that the boys were a little more all over the place in their scores, right? So that was your homework. You still have part C to answer, which says based on the computed MAD values for which distribution is the mean a better indicator or indication of a typical value. Who tends to score closer to 3 goals is what that is asking. Kyle, what do you think? Yep, he said that really quietly. The girls team, right? The MAD saying they get 3 goals on average would be more typical, a better indicator for the girls. All right, and we can base that on the fact that it has a lower MAD. Anyway, I'd like to thank you for watching this video. I hope you got your homework done. Please don't forget to like and subscribe if you haven't done so already. And special thanks to my 3rd period class. Bye. Have a great night, guys.